Hi, can you hear me?
Yes, ma'am.
Okay. Sorry for the delay. Actually, I was traveling. Just got home.
Oh, okay, no problem.
Did you do the questions from the redox reaction, that question paper?
Yes, ma'am. I did.
Okay. Today, let me first continue with the periodic table chapter. Let's finish that first.
Okay, ma'am.
So we were at the configurations, right? Wait. S block, P block, D block, and F block. And I told you about the configuration. This goes to NS 1 to 2. That means it either can be NS1 or it can be NS2. In P block, it would be SNS2 NP1 to 6. This means that NS2 and NP1, then NS2, NP2, so on till NS2, NP6. For D block, it's NS1 to 2 and N minus 1 D 1 to 10. And for finally F block, it's N minus 2 F 1 to 14 N minus 1 D 0 to 1 NS 2. Okay. Now what these are? Okay. So remember I told you about the quantum numbers?
Yes, ma'am. From chemical bonding chapter, right?
Yeah, like before starting chemical bonding, we did a little part of atomic structure. I told you there about the quantum numbers.
Yes, ma'am.
Yeah. So what are the quantum numbers? The four quantum numbers we have, those are N, L, M, S. Principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. Do you remember these?
Yes, ma'am. It was from structure of an atom.
Okay. So if I give you N is equal to 3, let's say, then what will be the values for L?
L L will be 3.
L will be 3.
No, 1 2. 0 1 2.
L will be 0, 1, 2. And what will be the values for M in that case?
M will be 3.
No, M won't be 3.
Will it be 2?
No. You have the notes from that those classes, right?
Yes, ma'am.
Take those out and tell me what will be the values for M, okay? You have the notes, right?
Yes, ma'am.
Okay, check the notes and tell me. Because we have practiced it a lot. It's fine. Like, forgetting is fine. Just take out the notes. That will be more fruitful. Just let me know even if you are not getting, okay?
Ma'am, will it be positive 2?
It will be one of the values will be positive 2. Yes.
And for S, it will
No, no,
be
no. There will be other values of M2.
positive 1, 0.
Mm-hmm. Positive 2, positive 1, 0.
Then negative 1, negative 2, negative 3, negative 4.
No, negative 1, negative 2. Bas. That's all. See, for n equal to 3, values of L will be 0, 2, n minus 1. Okay. So it
Yes,
is
ma'am.
1 and 2. N minus 1, 3 minus 1 is 2. Now for L, for the values of L, values of M will be from minus L to plus L. So like the maximum value of L. So here it's 2. So it will be from plus 2 to minus 2. Plus 2, plus 1, 0, minus 1, minus 2. Okay?
Yes,
Fine?
ma'am.
Okay. Now for S, we have two values of S. One is positive half, one is negative half. So we did this type of things a lot. Okay? Let me see how much you remember. Let's say I am telling you our principal quantum number is 4. And what will be the value of L? What will be the value of M? And what will be the value of S for the electron I have drawn here? Okay? This one. Okay? Okay.
Okay.
Wait and let me know.
Um, Ma'am,
Yes.
L is 0, 1, 2, 3.
No, I am asking you for the specific electron. No. Yeah, the values of L are definitely for n equal to 4, values of L will be 0, 1, 2, 3. But for this specific orbital I have given you, what will be the value for L? You have the notes?
Yes, ma'am. Is it 3?
Okay, let's see. For L equal to 0, this is S orbital, right?
Yes, ma'am.
Equal to 1, it's P, is equal to 2, it's D, is equal to 3, it's F. Now for L equal to 0, when it's S orbital, what will be the values for M? It will be 0 only. For
Yes,
P,
ma'am.
it will be -1, 0, +1. For D, it will be -2, -1, 0, +1, +2. For
Yes,
F,
ma'am.
we -3, -2, -1, 0, +1, +2, +3. Now we know that the values of M, every box here gets assigned a value like 1, 2, 3, 4, 5. Here we have 5 boxes, so every box will get assigned a single value. So in these cases, is L equal to 0, L equal to 1, L equal to 2, L equal to 3, in which case the M values are, there are 5 M values.
Yes, ma'am.
In which case there are 5 M values, tell me. In the first case, we have only 1 M value. In the second case,
Yes, ma'am.
we have 3. In the third case, we have 5. And in the fourth case, we have 7 M values, right? So here we need 5 values. So we will take this one. So when L equal to 2, that is our d orbital and it has 5 boxes. Okay?
Yes, ma'am.
Here our L will be 2. Fine?
Yes,
And
ma'am.
we assign the values of M like this: +2, +1, 0, -1, -2. We start from plus and end at minus. So here our value of M will be +2. And here the electron is up spin. The spin is up, not down. It's not the case here. This is up spin. So it will be plus up. Right?
Yes, ma'am.
So you remember it now?
Yes, ma'am.
Okay. So if there are 7 boxes, then what will be the value of L? 1, 2, 3, 4, 5, 6, 7. So if there are 7 boxes, that means L is equal to 3. That is our F orbital.
Yes, ma'am.
Okay. And if we assign the values of M, these are the values of M for L equal to 3. So it's -3, -2, -1, 0, 1, 2, 3. Right?
Yes, ma'am.
I'm asking you another one, a simple one. Just quickly answer me and then we will be able to understand what is that. In this case, I am telling you the value for N is 3. Then you tell me what will be the value for L, what will be the value for M, and what will be the value for N. Okay?
Okay, ma'am.
Okay. If you need reference, we have the previous ones.
Ma'am, NS.
Oh, sorry. S. S. You need reference? If you need reference, we have the previous one. Now answer me. What will
Okay.
be the other 3 quantum numbers for this electron? For the electron I have drawn here, okay?
Yes, ma'am.
Okay.
Ma'am,
Say, what did you get?
L is 0, 1, 2.
The values of L for n equal to 3 are 0, 1 and 2. But I am asking you for the specific case. In this case, what will be the value for L? You are absolutely right that if the value of n is 3, then the values of L will be 0, 1 and 2. But I have given you a specific case. So how many boxes are there?
3.
3 boxes. So if there are 3 boxes, that means that we will be having 3 m values, right?
Yes, ma'am.
So if we have to have 3 m values, then what should be the value of L?
3.
First, no. First assign the middle one to be 0, and this one will be minus 1 and this one will be plus 1, right?
Yes, ma'am.
These are the values of m. So tell me from here what is the value of m for this specific electron. In which box it is? It is in the 0 box. The value of m will be 0, right?
Yes, ma'am.
You are understanding this part, right?
Yes, ma'am.
Okay. Now we have got values of m to be plus 1, 0, minus 1. So here I have written that when the value of L is 1, we call it p orbital and the values of m are minus 1, 0 and plus 1, right?
Yes, ma'am.
So for value of L to be 1, the values of m will be plus 1, 0 and minus 1. That is 3 and we have 3 boxes here. So this will be L equal to 1, that's it, that is our p orbital. Okay?
Yes, ma'am.
This is in the m equal to 0 box, so m is equal to 0 and our s, the value of s will be
Positive 1 by positive 1.
positive half. Positive. Okay. Now one thing you see, now let's do it. N equal to 1. Let's do it for n equal to 1 and 2 first. N equal to 2. So if n is equal to 1, this implies that L will be equal to 0. And if n is equal to 2, this implies that L will be 0 and 1 both.
Yes, sir.
Imply that value of m will be 0 and this implies that value of m will be minus 1, 0, plus 1. This is one set, like
Yes, ma'am.
this set is for 1 and also we will have 0. It's for this one. For L equal to 0 we have m equal to 0 and for L equal to 1 we have m equal to minus 1, 0, plus 1. Okay.
Yes, ma'am.
Now if we draw, for the first case we will get only one box. Because value of m is 0, so we have only one value of m, so we will have only one box and the number of box will be m equal to 0 and also L is equal to 0, so it will be s orbital.
Yes, ma'am.
Now when we have n equal to 2 and we have two values of L, so one will be this one, this is for L equal to 0 and this is for L equal to 1. We know that L equal to 1 means it will have 3 boxes.
Yes, ma'am.
So this is L equal to 0, m equal to 0. This is L equal to 0, m equal to 0, but n equal to 2. And this is L equal to 1. And this one is m is equal to plus 1. This is m0 and m minus 1. Right?
Yes, ma'am.
Okay. Similarly, when we will have n equal to 3, n equal to 3 means we can have L equal to 0, we can have L equal to 1 and we can have L equal to 2, right?
Yes, ma'am.
For L equal to 0, the value of M we will get, that is 0. For L equal to 1, value of M we will get -1, 0, +1. For L equal to 2, values of M we will get -2, -1, 0, +1 and +2. Fine?
Yes, ma'am.
So one box we will get for L equal to 0, which is only one box. L is equal to 0 means one box. L equal to 1 means 3 boxes. And L equal to 2 means 5 boxes. Okay?
Yes. Yes, ma'am.
And if we assign the M values now, this is 0. This is L equal to 0. M value is 0. This is L equal to 1. This is L equal to 2. So this is our S orbital. This is our P orbital. This is our D orbital. Okay. You remember I have shown you the shapes of these orbitals?
Yes, ma'am. I have drawn that also.
Here the value is +1, values of M, +1, 0, -1. This will be +2, +1, 0, -1, -2. So you are understanding it, right?
Yes, ma'am.
Similarly, if we do N is equal to 4, so for N is equal to 4, what will be the values of L?
L will be 3.
L will be
0,
0,
1, 2, 3.
1, 2, 3.
Ma'am?
Now for L equal to 0, what will be the value of M? It will be 0.
Yes, ma'am.
Okay. For L equal to 1, what will be the value of M? It will be
Uh,
-0.
-1, 0, +1,
Okay.
positive
L equal to 2, it will be -2,
minus
-1, 0,
0,
and +2.
plus
And for L equal to 3, so for L equal to 3, there will be 7 values: -3, -2, -1, 0, +1, +2, +3. So for L equal to 0, we have only one value of M, that is M0, so it will have only one box. For L equal to 1, M value are 3, so it will have 3 box.
Yes.
For L equal to 2, M values are 5, so it will have 5 box.
Ma'am, these orbital structures, we call them lattice structures, right?
No, it doesn't come from lattice structure. Orbital structure are different, lattice structure are different. Lattice comes when we have more than one atom, no? And these orbitals are a part of one atom.
Yes, ma'am.
Orbitals are the space where electrons are oriented inside an atom. And lattice structure is something when more than one atom is a structure which is made of more than one atoms. Okay.
Yes, ma'am.
And for F orbital, we will have 7 boxes. 1, 2, 3, 4, 5, 6, 7. Okay. So this is L equal to 0, L equal to 1. Please make sure you are understanding this because this is from atomic structure and we are already studying it twice. So in the atomic structure part, it will be tough to repeat it again, okay?
Yes, ma'am.
So this is +1, 0, -1, +2, +1, 0, -1, -2, and this will be +3, +2, +1, 0, -1, -2, -3. Okay? Now, this is our s orbital, this is our p orbital, this is our d orbital, this is our f orbital. Okay?
Yes, ma'am.
Electron fills in this way. First 1, 2, then 3, 4, 5. Every box gets a single electron, then 6, 7, 8. Again, every box will fill with single electron, and then we will fill with the opposite spin electrons. Okay?
Yes, ma'am.
Okay. Similarly, here too. Total, how many electrons we have? Tell me the number of electrons for each orbital and total. Tell me how many electrons are there in s orbital, how many electrons are there in p orbital, how many are there in d orbital, and how many are there in f orbital.
Okay, ma'am. Ma'am, in s orbital, we
Hmm.
have one electron.
How we have one electron?
One orbital.
One orbital, and how many electrons had gone here? Yeah, one upspin electron, one downspin electron. I have drawn two electrons there. In one box there can be two electrons, right? This up arrow is one electron, this down arrow in one electron. So in this s orbital we have only one box, and in one box maximum two electron can stay. So here are two electrons. See, I have drawn two electrons here. One is here and another is here. No, one is plus half and another is minus half. I have told you about Pauli exclusion principle that two, like all the four quantum numbers of two electrons can't be same,
Yes, ma'am.
right?
Yes, ma'am.
So how many electrons are there in the p orbital?
6,
6. In the d orbital?
10,
10. And in the f orbital?
14.
14. Okay, good. Now we will learn to apply this. Now how this comes? This comes in this way. Like what comes first? 1s comes first or 2s come first? That's the question. So 1s means the principal quantum number is n is equal to 1, and s means l is equal to 0. Okay?
Yes, ma'am.
Similarly, when we will have principal quantum number to be 2, L value we can either have 0 or we can have 1, right? So
Yes, ma'am.
corresponding to S and corresponding to 1 it will be P. So we will call it 2S, and this we will call 2P because our principal quantum number is 2. Okay?
Yes, ma'am.
Similarly, principal quantum number will be 3. Values of L will be 0, 1 and 2. So we will call it 3s, we will call it 3p, and we will call it 3d. Similarly, again, if it's 4, then the values of L will be 0, 1, 2, 3. And we will call it 4s, we will call it 4p, 4d, 4f. Fine.
Yes, ma'am.
Now, how does the energy level goes on? So we need to write it this way. 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f. And we go like this. 1s, 2s, 2p, 1s, after that 2s, then we will have 2p. After that, we will have 3s. Then we will have 3p. After 3p, we will have 4s. Then we will have 3d. Like this we will go, okay? So what is the energy ordering sequence? It is 1s, then 2s, then 2p, then 3s, then 3p, then 4s, not 3d. After 4s, then we will have 3d. After 3d, we will have 4p. Like this, so on. So in the s
Yes.
orbital, so if I ask you that we are supposed to fill the electrons, fill the orbitals with the maximum number of electrons. So in the 1s, maximum how many electrons can be there? In the s orbital, there can be maximum 2 electrons, right?
Yes, ma'am.
So we will write this way, 1s, 2. Similarly, again, 2s, this is 2s. So 2 is the principal quantum number, but how many electron can be there? That is depending upon if it is S or P or D or F. Okay. So in S, 2 electron can be there maximum. Either 1 or 2. So 1 is 2, 2 is 2. Then coming to 2p, in 2p, this is the principal quantum number, and this P will decide that how many electron can be there. So if it is P, then there can be 6 electrons maximum. We have seen. So 2p6, 3s2, 3p6 again, 4s2, 3d10, 4p6, right?
Yes, ma'am.
Okay. So this is our energy ordering. We won't be needing every electron. See, for lithium, hydrogen and helium, in hydrogen we have only one electron, and in helium we have two electrons. So we will only need one s. We don't need all this part for hydrogen and helium, right?
Yes, ma'am.
Okay. So if we see hydrogen, so in hydrogen, we have only one electron. So if we write it this way, 1s1. This is the electron configuration for hydrogen. Okay.
Yes, ma'am.
Now for helium, we have two electrons. So we will write it down. 1s2. Helium is done. For lithium, we have three electrons. So for lithium, what we will do? We will write 1s2 because in s orbital, there can't be more than two electrons. So we can't write 1s3. There it will be 1s2. But what comes after 1s? After 1s, it comes 2s, right?
Yes, ma'am.
So it will be 1s2, 2s1. Okay? So in total, we have 3 electrons. 2 here plus 1 here. In total, we have 3 electrons. So after lithium, we have beryllium. Atomic number for beryllium is 4. So we will write it 1s2, 2s2. Okay? Fine.
Yes, ma'am.
Okay. After beryllium, we have boron. Boron is 5. So we will write 1s2, 2s2. Now what comes after 2s? Let's look at here. After 2s, we have 2p. So we will have 1s2, 2s2. So we have to have a 2 plus 2. 4 electrons are done. Total we need 5 electrons. So we will do 2p1. Okay?
Yes, ma'am.
So if we try to draw the orbitals, how we will draw it? For 1s, we will have only one box. This is 1 and 1 electron like this. 1s2 will be like 1s orbital. These are 1 electrons and 2 electrons. For lithium, this is 1s, then this is 2s. For beryllium, 1s and 2s2. For boron, 1s2 2s2, 2p1. Only one electron in the p orbital, right? So this is 1s,
Yes.
this is 1s, this is 2s. Sorry, this is also 1s, this is 2s. 1s, 2s, 1s, 2s, 2p. Fine? So
Yes, ma'am.
similarly, if I ask you, now this is called electron configuration. This 1s2, 2s2, all these type of things, we call it electron configuration. How electrons are configured in an atom. Now, if I give you carbon, which is 6, then can you tell me the electron configuration of carbon? What will be the numbers here? 1s dash, 2s dash,
3 is dash.
hmm?
3 is dash.
Yeah, 3s. Now, why 3s? After 2s, we have 2p. These are the levels. This is how this comes. Like 1, 2 comes after 1. Like that 2p comes after 2s. We have 1s, 2s, 2p, 3s, 3p, then 4s, then 3d. This is the serial, okay? 3s doesn't come after 2s. 2p comes after 2s, okay?
Yes, ma'am.
So what will be the numbers? With which numbers we will fill this dashes? Like here we had 1s2, we had 2s2 and 2p1. So what will be the number we will write here? How many electrons will be there in 1s? How many electrons will be there in 2s? And how many electrons will be there in 2p?
In each electron there will be two electrons, like one S2, S2, 2p2.
2p2. So in total we will have 6 electrons, right?
Yes, ma'am.
Okay, very good. Now you do it for nitrogen. There's 7 electrons. Then fluorine, there's 9 electrons. Then sodium, it has 11 electrons. And calcium, it has 20 electrons. Okay? Deduce the electron configuration for 4 of these and let me know, okay?
Okay, ma'am. Ma'am,
Yeah.
ma'am, for N7, I got 1S1, 2S1, 2P2, 3S3.
Minus 1, 2s1, 2p2, 3s3. How many electrons can be there in 1s? 2 electrons, right?
Yes, ma'am.
So if you have not completed the electrons in 1s, which is 2, you can't shift to 2s, no. Once you have fulfilled the total electron, you can give to 1s, okay? So you first give 1s 2 electrons. Then you have 5 electrons left. Now 2s can have 2 electrons again. So you give it 2 electrons. Now you have 3 electrons left. And 2p can have total 6 electrons. So it can easily accommodate 3 electrons, right?
Yes, ma'am.
This is how you do, okay? You first fulfill for 1s, then fulfill for 2s, then fulfill for 2p. And at which point you have more vacancies than electrons, that's where you stop. Like in 2p we could have had 6 electrons, but we had 3 electrons left, so 2p was the last point. We gave 3 electrons to it, so it will look like this. So if we try to draw it, this will be our 1s, this will be our 2s, and this will be our 2p. And if we align the electrons, 1s2, so 2 electrons, 2s2, 2 electrons, and 2p3. 1, 2, 3. Okay,
Yes, ma'am.
you understood it, right?
Yes, ma'am.
Okay, now do it for fluorine and let me know what you got. Uh, First let me know and then move forward to sodium, okay?
Okay, ma'am.
Yeah.
Ma'am, for fluorine, I got
Yeah, what did you get?
Ma'am, for fluorine, I got 1s2,
Hmm.
2s2,
Hmm.
2p3, and 3s2.
How many electrons you can accommodate in 2p?
3.
No. You can see in this is our 2p orbital, right? I have drawn a 2p orbital here. Let's take this one. This is a 2p orbital. So here we have
Yes, ma'am.
added upspin electrons. Similarly, we can add 3 more downspin electrons now.
Yes, ma'am.
We have added 3 plus half. Now we can add 3 minus half. So how many electrons can be there in 2p?
6.
6. So we have used 4 here. 1s2, 2s2. So 4 electrons we have used. So how many electrons are left? Total was 9.
Yes, ma'am.
We
So,
have 2 here and 2 here. Then how many electrons are still left?
we use 5.
We will use 5. We have used 4 and 5 are left, right?
Yes, ma'am.
So, and how many electrons can be there in 2p?
2p, 5.
2p in 2p there can be maximum 6 electrons, right?
Yes, ma'am.
And here we have 5. So all the electrons can be accommodated in 2p, right?
Yes, ma'am.
If it is more than 6, then we will go to 3s. If it is 6 or if it is below 6, then it can be accommodated in 2p, na?
Yes,
Okay.
ma'am.
Before going to sodium, do these two first. First, do oxygen, which is 8, and do neon, which is 10, okay? Do these two first and let me know once you are done with oxygen and neon. Fine?
Yes.
Okay.
Ma'am.
Yes.
Ma'am, for oxygen 8, I got 1s2, 2s2, 2p4.
Okay, very good.
And for neon 10, I got 1s2, 2s2, 2p6.
Very good. Now do for sodium and calcium, okay?
Okay, ma'am.
Yes.
For sodium 11, the answer is 1s2, 2s2, 2p6, 3s1.
Okay. Very
And
good.
for calcium, it is 1s2, 2s2, 2p6, 3s2, 3p6, 3d2.
2p6, 3s2.
3s2, 3p6, 3d2.
No, what comes after 3p? 3d doesn't
3d,
come after 3p.
3d.
No. What comes after 3p? 3d doesn't come after 3p. Remember the thing we draw? You have taken the notes?
Yes, ma'am.
Then see there what comes after 3p.
4s.
4s. So what it would be?
4s2.
4s2. Okay. Good. Now do for these. Calcium we have done. Scandium. Sc scandium, which is 21. Then titanium, which is 22. Then vanadium, 23. Okay? Do for
Okay.
these three.
Okay, ma'am. Ma'am,
Yes.
ma'am, for SC21, my answer is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1.
Hmm. Very good.
For 22, my answer is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2.
Okay. And for this one, it will be
1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d3.
Pvt. Now, one thing you notice for nitrogen, phosphorus, the last orbital that we call the valence orbital is p, right? For
Yes,
phosphorus,
ma'am.
it's for nitrogen, it's p, oxygen, it's p, neon, it's p. Similarly, for sodium, the last orbital is s, this orbital is s, and for scandium, it's d, titanium, it's d, vanadium, it's d, right? Depending upon these, we divided our periodic table in this part. If you look at your periodic table, you will see that there's a part like this. Then after this, we have a part like this. And after this, we have a part like this.
Yes, ma'am.
Apart from these, we have another part here. Okay. Now this is our S block. This is our P block. This is our D block. And this is our F block. Okay. Now what? All the elements in the S block, all of their valence orbital are S orbitals. So sodium is there, calcium is there, similarly hydrogen is there, lithium is there. Okay, fine.
Yes, ma'am.
Like all the atoms whose last orbital, that is the valence orbital, is S orbital, all of them are there. If we take more example, if we take you have seen sodium, you have seen calcium. If you see potassium, it's the same case. If you see magnesium, it ends with s orbital. Okay, quickly do for potassium and magnesium. Potassium is 19 and magnesium is 12. Okay, so quickly tell me the configuration for potassium and configuration for magnesium. Okay.
Okay, ma'am.
Yeah.
Ma'am.
Yes, you are done.
Yes, ma'am. Ma'am, for 19, I got my answer 1s2, 2s2, 2p6, 3s2, 3p6, 4s1.
2s2, 3p6, 4s1, and for 12,
1s2, 2s2, 2p6, 3s2.
so you see that all of these, they are ending with s orbital, right?
Yes, ma'am.
That's why
Yes,
these
ma'am.
are part of S block. So if you look at your periodic table, you will see that all these potassium, magnesium, calcium, also apart from this rubidium, cesium, francium, all these they are in the S block, right?
Yes, ma'am.
Okay. Similarly, for nitrogen, oxygen, and then fluorine, phosphorus, sulfur, aluminium, boron, carbon, and so on. If you see all these, you will see, and some of this we have seen already, all of these end with p orbital. Okay?
Yes, ma'am.
That's why all these are part of p block. And similarly, three we have seen. We have seen titanium, we have seen scandium, we have seen vanadium, and more of these like chromium, iron, copper, then silver, gold, niobium, then manganese, nickel, cobalt. All of them, if you try deducing their electronic configuration, you will see these are ending with d orbital. Like this was ending with s orbital, all they end with p orbital. These end with d orbital. Okay?
Yes, ma'am.
That's why these are part of D block. Okay?
Yes,
And
ma'am.
F block, that is that F block is something that we don't need that much right now. So, and this is the configuration. Now, if we compare it with the configurations we have written in the first, you will understand this is the common configuration. N means the principal quantum number. So, for S block, the last is either N1s1 or 1s2, right? I mean, sorry, not 1, like it's 1 is something, some number, either S1 and some number or S2, right? That's what we got.
Yes,
Yeah. Similarly, for P block, we either got P1, P2, P3, P6, whatever with a filled S, right?
yes, ma'am.
Similarly, this if, see this is what you got for is, let's say for scandium you got NS2, like for scandium you got 4s2, 4s2, 3d1. This is what you got for scandium, the last part. Okay. So you see, if here n is equal to 4, then n minus will be 3. So 1 to 10, that means it can be D1, D2, D3, anything it can be. So you see, we got 4s2, 3d1, right?
Yes, ma'am.
These are the general configuration of the periods. Fine?
Yes, ma'am.
Okay. Now, what will be your task from here? Your task will be, now once this part is done, you will see there are some things called atomic radii, then we have ionic radii, then we have ionization potential, then we have electron enthalpy, and we have electronegativity. Okay? Now, first thing you will do, you go through the periodic table you have in your book and try to understand the SPDF blocks. Okay, F block is not that important right now. Try to understand S block, P block, and the first two rows of D blocks. Okay, after that, in your textbook, these things are given. Just give it a read and try to comprehend what you are understanding. Okay, you don't have to understand everything, just give it a read. If you do that in the next class, when I will tell you about this, it will be very easy for you to comprehend. Okay, is that fine? Hello?
Ma'am, we don't have ionization potential.
You don't have ionization potential, you sure?
Yes, ma'am, we have enthalpy, ionization enthalpy.
Okay, it's the same thing. Ionization potential or ionization enthalpy, it's the same thing. Okay. Okay.
Yes, ma'am.
And your atomic structure, that chapter is actually done today. What we have done, that is the part that was left in that. Okay. Like we
Yes,
have
ma'am.
all those Rutherford model, Niels Bohr model, we did all those. No, we already
Yes, ma'am.
covered those. So this part was only left. We have already did the quantum number part. This electron configuration part was left. So that is done today. So your atomic structure is done.
Yes, ma'am.
Structure is done. So in the next class, you surely give these topics a read. Okay. Like just have a basic concept. You don't have to understand everything. I will explain it in the next class. So after we will see the trends of this along the row and along the column. And after that, we will go to the chapter equilibrium. Okay.
Okay, ma'am.
Okay. Fine. So good night.